Okay, so we're only going to look at one problem in this video, and that's all we need to deal with order of operations problems with variables, at least at this level, until we get to more complicated ones later in your career. The rules are the same. We're still identifying terms. We're still simplifying each term as much as we can, and then combining like terms if there are any like terms. So this problem might look familiar to you if you watched my previous video. It's the same problem, but I tossed in a couple of variables here and there. So if we look at the terms, trying to identify what's what here, this minus sign is still separating the 2 from the next term. Then I have a plus, a minus, but that's inside the parentheses, so that's still going on here. Minus, okay, so that's adding the opposite of what comes next, which is 2 times, well, this bracket starts here, it ends there, so that's all part of this one giant term. Right? So I've identified my 4 terms. Some problems might all be one term. If, let's see if I can do this. If this weren't here, then this, and this was my whole problem, this is all one term. It's starting as a multiplication, 2 times brackets, that's one term. Then I'm looking within the grouping symbols. Within the brackets, I have 2 terms, the 5 and the parenthesis. Within the parenthesis, I have 2 terms, the 3n and the 4p times 7. But for this whole problem, that's all one big term. Right? Now, I wasn't scribbling this out. This is part of my problem, so I can identify each term and simplify it. So 2 is 2. That's easy. 6n times 14. Well, 6n means 6 times n times 14. I can use the associative property. 6 times 14, I hope you remember this from last time, it's 84, is being multiplied by n. Right, that's just associative property. Now, I'm not going to be able to subtract this from 2 because these aren't like terms. This is counting 84 halves, or 84 dozen, or 84 3/15. Who knows what n is? But it's 84 of these. I can't subtract that unless 2 is also counting n's. So I'm going to leave that alone. Next term, 3 times this. Last time I did 8 minus 6 first, but 8 and 6n are not like terms. So now I have no choice but to distribute 3 times 8, 3 times negative 6. Right, the 3 is positive, plus 3. The 8's positive, so 3 times 8, that's 24. Let me move all of this down here. There we go. So that's 24. 3 times 6 is 18 with a single negative and with an n. All right, so simplifying this, I get 24 minus 18n. But I've got some more n's over here, so I'll combine those eventually. I've got a 2 over here that I'll combine with the 24 eventually. But let's look at this last term. Right? Notice I've already gone down 2 rows when I still have space over here to go up. That's why it's so important that we're organized and writing each new line is equivalent to the line previous to that. So looking over here, I have 2 times all of this. Well, what's in here? I have 5 minus all of this. Okay, let's look inside these parentheses. I have 3 times n. That's just 3n. There's nothing to do there. 4p times 7. Again, the variables with the 4 but it's all just multiplication. So 4 times 7 is 28 plus the p there. Now, it might look like I have 3 terms here, but this minus is kind of sneaky. Just like the 3 had to be distributed, this minus also has to be distributed, right? Minus could be thought of as plus a minus 1. That negative applies to the 3n, and that negative applies to the second term, the 28p. I have to distribute that negative in order to get rid of these parentheses and just have 3 distinct terms here. Now, even though I have 3 terms, they're 3 unlike terms. This has no variables. This is the variable n. This is the variable p. Nothing I can do there. So I have to just distribute the 2. Now, I could say 2 times 5 is 10, but especially when we have negatives being multiplied by something with a minus in front of it, I strongly urge you, think of this not as a 2 with a minus in front, but as plus a negative 2. And then this plus doesn't have to be distributed the way this minus had to be distributed, because I'm already dealing with the negative 2. I don't want to distribute the 2 and then separately distribute the negative. I want to take care of that all at once. So these first terms are all the same. Whether I write plus, negative, or minus, same difference. But here it's negative 2 times 5, so that's a negative 10. Negative 2 times negative 3, 2 times 3 is 6. Negative times negative, that's now a positive, right? The opposite of a negative is positive. 2 times 28 is 56, with the opposite of that minus giving me a positive. Don't forget your p. So I have my 3 terms here that are now separated from these brackets. These terms, like the others, can now be combined at will. So I have 1, 2, 3, 4, 5, 6, 7 terms to keep track of. I want to hunt for like terms. So just moving left to right, this first term has no variables. And 24 has no variables, and 10 has no variables, and p. So these 3 terms are all constants. 24 plus 2 is 26. 26 minus 10 is 16. So I get 16. I could say 24 minus 10 is 14. 14 plus 2 is 16. Or 2 minus 10 is negative 8. 24 minus 8 is 16. Right? Don't do it 3 different ways. Just pick one way, and as long as you're paying attention to those signs, you're fine, right? For me, going left to right here was just as easy. 24 and 2, then minus 10. Okay, now I see the next term has n's on it. I'm going to double underline that so I can see it's different from the single underline terms. Here's another n term. Here's another n term. So again, I've got 3 terms that I have to combine here. This term is going to the left. It's got a negative in front of it. This term is going to the left. It's got a negative in front of it. So I'm going to combine all those negative terms. 80, 98, 99, 101, 102. So that's 102n plus 6n, going opposite directions. So 102 minus 6, that's, let's see, 102 minus 2 is 100, minus 4 more, that's 96, so minus 96n. I think it probably would have been easier to look at 18 and 6 going opposite directions. So 18 take away 6 is 12, so it's negative 12. All right, negative 84 and negative 12, 84, 94, 95, 96, negative 96. Right? Easier for me to do in my head. But we don't have to do everything in our head. So we did the constants, we've done the n's. All that's left is this single p term. no other p terms to combine it with. So 56p stays unchanged. And these three terms cannot be combined. So that's my answer. Now, often we like putting the constant term at the end and going in alphabetical order. That's fine. N comes before P, so I'm going to put the 96 N first, remembering that it's negative, then the P term, then the 16. When I have kind of random variables like N and P, it's not such a big deal. When we have X and Y, generally we're going to put the X term first before the Y term. When we have X squared and X, and then a term without variables, we tend to put it from highest exponent on the way all the way down to the lowest exponent, which is no variable at all. But here, either of these are fine. What we don't want to write is something like this. I don't want to leave a plus and a negative together as a final answer. That's considered unsimplified, right? You haven't finished making the problem as easy to see as it is. Whether we have these parentheses here to separate the plus and the negative, or whether we're kind of sloppy with the plus negative without the parentheses separating them, either way, it's not good. We want to have minus in our final answer if the term is in fact negative. Of course, if the term turns out positive, then we're going to write plus. Okay. I hope understanding all the steps for this problem gives you enough insight to handle the other problems that are like this, especially the easier ones that are just like this for the entire problem. But I've separated out all the steps. It's still the same 3 steps. Pay attention to the operations and which values and which variables, which numbers are inputs to which operation within the problem. And you'll be good.